Hi there, Isaac here. This is my, I think second? Yeah, I'm pretty sure second chemistry video. This video, I'll be going over more in depth about nomenclature, and as you can see here, these are different like compounds of nitrogen. These technically, some of these are compounds, some of these aren't. They're more groups which add on to existing like hydrocarbons and other things which we'll be talking about. But one thing we'll be talking about is cycloalkanes, which is very interesting. So just here we have amino groups, which is NH2, and technically if it was on its own it would be negative. We have nitrogen dioxide, so it would be a nitrogen with a double bonded oxygen and then oxygen with a single bond. So I think, well, when it would it connect here? It would actually not. It would connect to nitrogen. Even though it forms 3 bonds, it's kind of 4 bonds, but not technically, because then this becomes slightly positive. It's a little bit weird, and the word is like nitro. And then this is NO, where you connect it here, nitric oxide, or slightly negative. And this is nitrous oxide, which is 2 nitrogens connected like this. So we have a nitrogen here, double bonded oxygen, and a nitrogen which can connect. So this R is, let me pull that up. Yeah, so these are the groups which we'll be talking about today. We'll be talking about nitrogen groups within hydrocarbons. We would talk about some just normal alkanes with nitrogen groups, but also some cycloalkanes. So remember, nitrogen can technically form 3 bonds, but kind of like every single, I'm pretty sure, element can form 1 extra bond, other than the noble gases. Actually, no, one of them I think can. Anyway, most of the elements can form an extra bond because in the presence of really strong acids, can form really weird reactions and weird things where a carbon can have like 5 bonds. It's very unusual. But normally, in normal standards, every element has the amount of bonds that has the amount of electrons it needs to lose or gain. Kind of. So this is this. So remember the equation. This was our equation for alkanes, if you remember, where we had methane, ethane, propane, butane, pentane, hexane, and so on. And they're all gases until about pentane, I'm pretty sure. Yeah, I got that wrong in my last one, but when you get something wrong, remember, don't be embarrassed, just accept that you got it wrong and build upon that. Instead of going, no, I got it right. Yeah, I did get the wrong. People sometimes you get things wrong. Okay, so this, remember, is the equation that we had last time. As well, remember we had for alcohol groups, which is the same equation, one single thing. Alcohol groups, which is just the alkanes with an extra oxygen, so you've got an OH group, so you take away the HDN, for example, so we have ethane. Remove the hydrogen and no H, which becomes F, or alcohol. Because the thing is with chemistry is there's many names for one thing, which does get a bit annoying. It can be helpful, but it also can not be helpful because it can make things really long or can make things very similar to others, very confusing. Chemistry, because of how chemical elements work, there are so many possible chemical compounds that most of them are too unstable to actually exist more like the second and or intermediaries, so we'll probably never really observe them that long, or there's just many things that are undocumented because it's just kind of hard to see that they're there because there's so many possible compounds, so many possible iterations or combinations. Well, so here's the 2 equations. So if we have this, boom, this is 1, 2, 3, 4, 5. 5 points, which means it's pentane. Remember how that works? You could also, instead of just adding like an OH group to make it pentanol, you could also add a halogen. Halogens are the groups like fluorine, and so on. So let's do chlorine. Let's do chlorine. Now, when you start getting slightly more complicated and naming chemicals, you have to start doing numbers. Where you have to find it from biggest number to smallest most of the time. So if we count, you'd start from one side and the other side. 1, 2, 3, 5. But since it's in the center, doesn't matter which really way we go, it's always going to be 3. So this would tell you 3. So it'd be chloro pentane, and then you'd put 3. Here. This is basically telling you there was a 3 on the 3 spot on the 3rd carbon on the pentane. There is a chlorine atom, so 3-chloropentane. It's not actually too difficult, and because of that, the hydrogen would be missing. So it would be like CnH2n plus 1. Because since chlorine only has 1 bond, it replaces the hydrogen, which can also form 1 bond. Oxygen, since it can form 2 bonds, if you replace the hydrogen, it can have another hydrogen to replace that. Therefore, you don't lose or gain any, but yes you do. So if you produce if you have a nitrogen, you can have an extra hydrogen. So, yeah. We have to do another one. Let's say slightly more. A little bit more complicated. This is 1, 2, 3, 4, 5, 6, 7 carbons. So heptane, oops, there's an OH, heptanol. So you could go 1, 2, 3, 4, 6, 7, 4, 1, 2, 3, 4, 6, 7. Now with this, since the OH is over here, if this chlorine was over here, you would say, I'm pretty sure, yeah, so you count from here, 1, 2, chlorine would be over here. Since you do it like this, wait, so hold on. Yeah, I think you, wait, which way would you do it? 1, 2, 3, 4, 5, 6. Hold on a sec. Yeah, sorry, yeah. Yeah, so this is 6, you do it as 6. 6, no, hold on. 6, 4, hexanol. Now, you also put a number here because it's for the anol or the OH group. So this is a 6, this is 1. So 6-chloro-1-heptanol, which means there is a chlorine on the 6th carbon and a OH group on the 1st carbon. So you count kind of backwards. So that means it would be the other way around. That means it would kind of like the other way around. So this, if this was over here, this would be over here. It's a little bit confusing. It's actually easier with some other chemicals, surprisingly. But anyway, I don't know, my brain just gone blank because when I record my videos, it's normally kind of late because I'm doing other things. Okay, let's do another one. Yeah, we'll do 1, 2, 3, 4, 5, 6, 7. We'll just do one more. So we have pentanol. Now I'm going to add a nitrogen group. Okay, let's do yes. So you can write it like this because if the hydrogens were here, that'll be symbolizing that's connecting to hydrogen sometimes. I mean, you can write NH2 instead of H2N, but I just prefer to do like this because it just feels less janky. So this, remember, is an amino group. This is 1, this would be 5. 1, 2, 3, 4, 5. 20 more. So it's 5 amino. This is nitrogen. Or you could write it, I didn't do it with the last few, but so you have C or 5, since now there is extra hydrogen, so it would be 10. So 2 times that, you should get 10 plus 2, 12. We add the extra hydrogen, it's 13. This is not saying nitrous oxide, nitrogen oxide, but it's just kind of saying that. Or you could do NH2CH. As I could write it more standard. I'll give 1 for you to do. Actually, wait, hold on, just before that, I'll show you what happens if you have more than 1 halogen. 1, 2, 3, 4, 5, 6. We have hex. Just liquid, I'm pretty sure. So, we can already write that out. If you have, let's say, bromine, which is a halogen, let's say we have 2 bromines. So we have, actually no, we'll make it X and all will go in OH. Because sometimes it makes it simpler. So we put a bromine. Bromine is written as big B, little r, bromine. Here at the last carbon. We'll put 1 here. Last carbon, so we have 2 bromines, which should write as dibromo. So dibromo. But for the numbers here, we write 2 numbers, which would separate by a comma. This is meant to be dash, but so if you have 2 bromos, since this is 1, 2, 3, 4, 5, 6, that's 4 and 6, so 6, 4, 6, 4, dibromo 1 hexane, 4, 6, 6, H minus 2 hydrogen, so times that by 2 is 4 now, so that's 12, so it's 14, minus 2, so it's just 12. Now, sometimes the bromines are put here. There is certain ways you can do it which are more formal, but I kind of like it like this, where it goes carbons, hydrogens, halogens, oxygens, or nitrogen groups there. Okay, so this is 6,4 dibromo 1 hexanol, C6H12 Br2O, or you could write it as BrCH2. Here, there's even, that's just a CH, I think it's CH, yeah, I think so. CH, kind of read, like, it's, the extended form is a bit long, BR, CH2, 2, CH3R, CH2, 3, OH. Because chemicals, you might, from watching these videos, because I'm going to do, I'll keep doing more, about chemistry is you'll understand why medicines and things like the backs of like containers, like hand sanitizers, not really hand sanitizers, but products that we will use, they have really, really long like names of our ingredients. That's just because of chemistry, of how you name things. And it might sound scary, but most of the time it's very simple. They're not really that dangerous. They just sound scary because their names are really long. With chemistry, it's just like that. Now there's something very interesting called a cycloalkane. Cycloalkane. And I think cyclo sounds like, if you're cycling on like a bike, it's a closed loop of an alkane. So if you have an alkane, you know how it's like, you kind of bend it into a shape. And the name of the shape corresponds to the name, like, how we have heptane, pentane. The start bit of the ane corresponds to a shape now. So when I was teaching myself chemistry, I actually found it easier to understand these. I mean, it was fairly easy in general. So if we have the first cycloalkane is propane, cyclopropane. You can't have it for methane or ethane because they're too small. You can't make them into a shape because ethane is just a line and methane is just some arms, which is like a point. So cyclopropane. So for every alkane bigger than ethane, you put the name after a cyclopropane. Wow. Cyclopropane is written like a triangle. So we have C. Okay. So, and then you're doing hydrogen. So the formula for cyclopropane is CH, and then so you have 2N because you have to take things away because it's closed. So this is the formula for cycloalkanes. And then you have cyclobutane. That's not very good. No, it's not going to go. Butane, often used in lighter fluid. So for this, you would have a square, but it's close enough. You'd have like a 4. Two hydrogens on each carbon, so it's C4H8. You can kind of have alcohol groups, but it just gets a little bit weird. Now with these groups, what you can do is the name also kind of changes. So let's say if we have cyclopropane, so let's say it has a chlorine on it. What would you call it? You call it you could put 1, but you don't really need to put 1. There's only 1, so you don't have to distinguish where it is, unless there is some other element or compound. Oh, group. Actually, no, it would be more group because it wouldn't be compound. So cyclopropane. You can combine just a normal alkane with a cycloalkane. So let's say we have this, which is normal cyclobutane, and you combine it with its carbon, which is 1, 2, 3, 4 carbons. So this is butane. Cyclopropane. And you have, you know, 3 hydrogens, 2, 2, 2. And for this, you lose 1. Yes, you lose 1. Minus 1. So you write it as, I think it's butane, cyclobutane, which is a bit janky. Let's see. And then, you know, we've got the double hydrogens, because they're the center ones. Triple. And then you'd have 1 here. So it's C, 8, H, 2, 4, 6, 8, 10, 12, 14, 16. So it's C, it's still double, which is interesting. Which is, this means this is equivalent to cycloalkane, because remember of this, which is very interesting. So you would call it, I'm pretty sure it's butane, cyclobutane. Where is it? Butyl. No, it's butane, cyclobutane. This is one of the janky ones. I don't think it shows that one. So let's just change it a little bit. So we have. That's not very good. It's gone. But this is cyclopentane, and cyclopentane has a chlorine and another chlorine. So you would have cyclopentane. So you have 2 chlorines. It's chloro, remember, or dichloro. So you could count it 1, 2, 3, 4, 5, or 1, 2, 3. So it could. So what you do is you actually go from the 3, so 3, 2, 1. So it's 3, 1, 3, 1 dichlorocyclopentane, or you do C, 5, H, 8, and 2 chlorines. There you go, you get 3, 1 dichlorocyclopentane. Okay, hold on a sec, let me just pause. I just need to do something. It'll just take like a second. Well, for you, it'll just be like nothing. No, I just have to clean my board because sometimes it gets repetitive, so you might clean my board over and over again. Okay, so now let's do more complicated. So we have this. Do you know what the name of this would be? No, it's a little bit complicated because we have a triangle and O. So this is a cyclopropane. You have an NO, which is nitric oxide cyclopropane. So there's only one of them you exactly need to distinguish. So it's C3H. So 3, 6, 5, and nitric oxide cyclopropane. Now let's get this. Do you know the name of this hydrocarbon? I'm just looking at it. You can pause it if you want, or you can just continue to watch. So 1, 2, 3, 4, 5, 6, 7. 7. Actually, 7. Yeah, should we do 7? Yeah, I guess we'll just do 7. Why not? Actually, you know what? I'll make it a little bit more complicated. We'll add the name of this, since it has 107, that means it would be a heptane, but since there's no H, heptanol. There's a chlorine here in the middle, and there's an amino. So we'll start from here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 4 is going to be 4. So it's not 1, 2, 3, 4. Amino, 4 chloro, 1 heptane. Yeah, that's basically it, and you can write it as well. Just remember it's 7. As removed a hydrogen here, but we gained one here, so it's still the same. So 2 times 14. And now we have a nitrogen, a chlorine, and an oxygen, so it does get a bit weird. I think it's chlorine and yeah. Or NH2, CH2, 3, Cl, CH, CH2, 3, OH, 4, 7 amino, 4, chloro, 1 heptanol. That's that big weird hydrocarbon. Now we'll do one last one before I sign off because it is getting late. So, okay, let me think what could we do? Yes. There's something called nitromethane, which is a methane. We have nitrogen. This is interesting. Remember, as I said, 4 bonds isn't really allowed, but kind of is. So over here, it's a negative, it's also slightly positive over here. So CH3. Any nitro or some alkane, and it's quite unusual. So we'll have one. You know the name of this, and that's the signing off. I will give the answer. So because it has 6. There's a nitrogen dioxide, or we would say nitro because it is shorter. Nitrohexene. I mean, it doesn't exactly matter if it's 1, 2, 3, 4, 5. If it's 5. It doesn't really matter, so we can put 5 or 3, but we could just say 5. So 5 nitrohexene. Wrong. So yeah, that's all for today. Thanks for watching and stay curious. Goodbye.